Now the fifth question is points A 3, 1, B 12 minus 2, C 0, 2 cannot be the vertices of a triangle. So if we prove that if its area is 0, then these points are collinear and they cannot be the vertices of a triangle. So this is a true statement, and we are going to prove that its area is 0. So area of a triangle is equal to half x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. This is x1 y1, this is x2 y2, and this is x3 y3. Just substitute the values. You will have 3 minus 2 minus 2 plus 12, 2 minus 1 plus 0, 1 minus minus 2. This is equal to half minus 12 plus 12 and plus 0. That is half into 0, that is 0. It means area of a triangle with these vertices is 0. So it implies points are collinear. So it implies they cannot be the vertices of a triangle. So true statement. Now the sixth question is points A 4, 3, B 6, 4, C 5 minus 6, and D minus 3, 5 are the vertices of a parallelogram. Now suppose this point is A, this is B, this is C, this is D, and its coordinates are given. If it is a parallelogram, then their diagonals bisect each other. It means midpoint of AC should be equal to the midpoint of BD. Now this is a false statement. We are going to find the midpoint of AC and midpoint of BD. Now midpoint of AC is 4 plus 5 by 2, 3 minus 6 by 2. Now midpoint of AC is 4 plus 5 by 2, 3 minus 6 by 2. That is 9 by 2 and minus 3 by 2. And midpoint of BD, 6 minus 3 by 2, 4 plus 5 by 2. That is 3 by 2 and 9 by 2. Since midpoint of AC is not equal to midpoint of BD, it means they are not the vertices of the parallelogram. Because in a parallelogram, diagonals bisect each other. It means midpoint of AC should be equal to midpoint of BD. So here the coordinates of the midpoint of both the diagonals AC and BD are not equal. Diagonals don't bisect each other. So they are not the vertices of the parallelogram. So false statement. Now the seventh question is, a circle has its center at the origin and a point P 5, 0 lies on it. The point Q 6, 8 lies outside the circle. Now this is a true statement. So center is the origin and P is the point which lies on the circle. Now center is the origin. Let the point O is 0, 0. This is the center, and P is the point 5, 0 which lies on the circle, and OP is the radius. If this point lies on the circle, then OP is the radius. If the distance between OQ is greater than the radius, is greater than the radius, then point Q 6, 8 lie outside the circle. So we are going to find first radius OP, which is equal to 5 minus 0 whole square plus 0 minus 0 whole square, that is equal to 5 square, that is equal to 5. Now the distance OQ is equal to 6 minus 0 whole square plus 8 minus 0 whole square, that is equal to 36 plus 64, that is equal to 100, root 100, that is equal to 10. So here distance OQ is greater than OP, which is the radius. So point lie outside the circle. So it implies point Q68 lie outside the circle. So true statement. Now the eighth question is the point A27 lies on the perpendicular bisector of the line segment joining the point P65 and Q0 minus 4. Now this is a false statement. Now the point A27 lies on the perpendicular bisector of the line segment joining the point P and Q if AP is equal to AQ. So here first I'll find the distance between AP, then I'll find the distance between AQ. If both are equal, then this point lies on the perpendicular bisector of the line segment joining the points P and Q. So let us find AP first. Now A, coordinates of A is 27, coordinates of P is 65, coordinates of Q is 0 minus 4. So AP is equal to 6 minus 2 whole square plus 5 minus 7 whole square. That is equal to 16 plus 4. That is equal to root 20. That is equal to 2 root 5. Now AQ is equal to 0 minus 6 whole square plus minus 4 minus 5 whole square. That is equal to 36 plus 81. That is equal to 117. That is 3 root 13. So AP is not equal to AQ. So it implies the point A doesn't lie on the perpendicular bisector of the line segment joining the point P and Q. So false statement.